Hey guys, week three's assignment. Hope everyone's still doing well at home. We're working on scatter plots this week. For a quick review, remember when a linear function fits data, scattered data well, there's a linear association between the variables. For example, the relationship between the height and weight of 25 dogs with the linear function whose graph is shown in the scatter plot. Because the model fits the data well and because the slope of the line is positive, increasing for both variables, we call this a positive association between the dog's height and the dog's weight. What do you think that the association between the weight of a car and its fuel efficiency is? Well, if you think about it, the heavier a car gets, the less gas mileage it probably is going to get. So, because the slope of the line that fits the data well is negative slope, as the weight increases, the miles per gallon decreases, we say that there's a negative association between the fuel efficiency and the weight of a car. That is what scatter plots was all about. So let's talk about good fit and bad fit. The scatter plots both show the year and price of the same 17 used cars. However, each scatter plot shows a different model for this relationship between the year and the price. So let's look at them. Look at diagram A and look at diagram B. Which one is the better fit for the data that is shown? Which one follows the trend of the data better? For how many cars in diagram A does the model make a good prediction for its price? Diagram A, does it make a good prediction for this price? B, for how many cars does the model underestimate the price? And C, for how many cars does it overestimate the price? So basically we're looking for how many are close to the price, how many fall above, and how many fall below the estimated value. Okay, we'll do the same thing at B. Well, if we look at A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 that fall below. And my pen's not working. We have 1, 2, 3, 4, 5, 6, 7, 8 that are above. And then we have like about 1, maybe 2 that fall on the line. Let's look at B. Well, if we count the data points that fall below the estimation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 below, and 1, 2, 3 above, and pretty much none on the line at all. So if we look at those, which one follows the data better? Well, the one that follows the data better, of course, is A, because it follows the trend of the data better. Question 3 says, for how many cars does the prediction made by a model in diagram A differ by more than $3,000? By more than $3,000. So from here, we have 1, 2. From here, we have 3, 4. 4 more than $3,000 above. Okay, so we write that 4 for model A, or diagram A. Okay, if we come back to B, we have none $3,000 below on diagram B. None that are $3,000 above the estimate. But let's look at those that are $3,000 below the line. For A, and this is a gap of $3,000. So there's not one here. This one could be getting close to $3,000, so we'll count that one. But there's only one below. Okay, so that gives us a total of 5 for diagram A. Now let's look at diagram B. How many are 3,000 below the estimate? Well, there's 1, 2, 3, 4, 5, 6. Nope. 6 more that are below for diagram B. So there's a total of 6 there that are more than $3,000 away. So which model does a better job of predicting the price? Well, from what we've seen, it's going to be diagram A. We have a scatter plot that shows sale price for several food items, Y, and the cost of the ingredients used to produce those items, X, as well as a line that models the data. The line is represented by the equation Y equals 3 4/800 $3.48 times the cost of the ingredients plus the 76 cents. What is the predicted sale price of an item that has ingredients that cost $1.50? Well, if we substitute that into our equation, we get $5.98 is the predicted cost. Our predicted costs will then come in on the graph where I have the red dot. The next question asks us, what is the predicted ingredient cost? Now we're looking for X this time instead of Y. So if we substitute the sale price of $7 in there, then we can solve for X. First, we subtract the 76 cents from both sides, which leaves $6.24 is equal to $3.48 times the cost of the ingredients. If we divide both sides by 348, then we come up with an approximate cost of the ingredients of $1.79 for X. But as you see, even going to statistics and probabilities, we're still using our basic algebra skills of solving equations, whether they're multi-step equations, linear equations, or what have you. We're still going back to our algebra skills. So this is why it's important that you develop them completely. In question 3, it says, what is the slope of the linear model? Well, our linear model is Y equals 3 4/800 times X plus 76 hundredths. So our slope in this case is $3.48 per what? Well, it's per cost of ingredient. That's how much they charge back for every cost that they put in for the ingredient. So in this case, if they put in $1, they charge $3.48 for the cost of the ingredient. So they charge $3.48 per $1 cost of ingredient. What is the y-intercept in this linear model, and what does it mean? Well, if we look back at the y-intercept, it's 76 hundredths, or 76 cents per item, regardless of what the cost of the ingredients are. So therefore, it could be packaging, how they package it. It could be many things. It could be a fee. Any of those things could be our y-intercept there, or our initial charge. So let's see. Are you sure you've got it? The scatter plot shows the number of times a player came to bat and the number of hits they had. The scatter plot includes a point at 318 and 80. What is the meaning of this point in this situation? So if we look, the X value are our at-bats, the Y values are how many hits that the player achieved. So what does that point mean? For 318 at-bats, the player hit 80 times, or got 80 hits. Does this... Okay, so if we draw, or try to draw, a scatter plot, a line of best fit, then we want to follow the trend evenly and divide it evenly. Let me use a red pen so we can see if we do well. Is my graph a good fit for this line? Well, let's see. We've got, most of those are on the line. We've got 1, 2 here below it. 1, 2, 3, 4, 5 above it. So I was a little off, but with those lines, the points so close together, we're going to call it good. It probably could have shifted up just a tad diagonally in this direction. But for the most part, I'd say it's a good fit. Is this a positive or a negative association? Well, as the number of at-bats go up, what's happening to the number of hits that the batters are getting? Well, as the number of hits go up, at-bats go up, the number of hits increases. So this is a positive association. There's the end of week 3. That was short and sweet. See you soon.